All right, our next problem is the square root of 7x minus 7 equals 2x minus 9. Okay, so I've got a variable under a radical, which means I'm going to check my answer. I notice that the variable under the radical is by itself on the left. So I'm going to go ahead and square both sides. And that way I can get this x out. So the left side pops out. The right side I'm going to have to FOIL. So I've got a 2x minus 9 times a 2x minus 9. So that gives me a 4x squared minus 36x plus 81. 4x squared minus 36x plus 81. So I see a positive x squared term. So I'm headed down the road of factoring, quadratic formula, whatever. So I'm going to bring both of the terms on the left over to the right. So that's going to give me 0 equals 4x squared negative 36 minus 7 is going to be a negative 43. And then 81 and 7 is 88. Okay, so again, we could guess and check through factoring and whatever. I'm just going to go ahead and use quadratic formula because I don't want to spend 28 million years guessing and checking. So quadratic formula, my A is 4, my B is negative 3, my C is 88. So I have x equals negative b, which is positive 43, plus or minus b squared. So 43 times 43 is, oops, sorry, that's not right. 43 times 43 is 1849. Minus 4 times a times c, all over 2a, which is 8. 2 times 4 is 8. All right, so I'm going to do 1849 minus 4 times 4 times 88. And that's going to give me 441. So I have equals 43 plus or minus the square root of 41 over 8. And I happen to know that the square root of 441 is 21. Okay, so that gives me 43 plus or minus 21 over 8. Well, 43 plus 21 is 64, and 64 over 8 is 8. Okay, 43 minus 21, 43 minus 21 is 22 over 8, and both of those are reducible by 2, so I'll get 11 fourths. Okay, so I got to check my answers, make sure that these work. So I'm going to try 8 first. So I have 7 times 8 minus 7 needs to equal a 2 times 8 minus 9. So this gives me 56 minus 7 is 49, and that equals 16 minus 9, which is 7. Square root of 49 is 7. 16 minus 9 is 7. So both of those work. So I'm allowed to use 8. Now we're going to try 11 fourths. Okay, and I'm just going to use decimals, just because it'll be a little bit easier than diving through with fractions. All right, so I've got 7 times 11 fourths. So 7 times 11 fourths minus 7 is, and I get 42. So on the left side, I've got the square root of 42. Okay. Okay, that's not right. I just knew that wasn't right. All right, 7 times 11 fourths minus 7, sorry, is 12.25. So on the left, I get 12.25. Does that equal 2 times 11 fourths minus 9? So 2 times 11 fourths minus 9 gives me a negative 3.5. Okay, and I can tell you right now that's not going to work because the square root of a positive is a positive. So a positive number cannot equal a negative number. So 11 fourths did not work. You've got one solution, and it is 8. All right. For the next one, we've got y equals 3x minus 2 under a radical. And I'm supposed to find the domain, and I'm supposed to find the range. Okay, so first of all, what is your parent function? Your parent function is the square root of x. Where is your variable? It's under a radical. Does it have an exponent? No. So my parent function looks like this. Okay? So I know that the domain of any function for our purposes is all real numbers unless I see variables under denominators. Okay, so I need to fix my domain. So grab the argument. Say you need to be positive, which means you're bigger than 0, but you can also be 0 because the square root of 0 is 0. So that works. All right, so I'm going to add 2 to both sides. So I get 3x is 2. And then I'm going to divide both sides by 3. So I get x equals 2/3. Okay, is greater than or equal to. Okay, so my answer starts at 2/3. It can also be 2/3. So if you graph that on a number line, okay, you're looking at everything like that. So my domain begins at 2/3 and goes to positive infinity. Okay, what's my range? Well, look at your picture and notice that your range would be adjusted if I added or subtracted anything after the radical, and I didn't. So what's the very, 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 very lowest y value that you're going to be able to give me? It's going to be 0. And then what's the very, very, very tallest y value? It'll be infinity. So also note that the square root of any number cannot be negative. Okay, so the square root of this cannot be negative. So your y's can't be negative. Okay, so those are your answers. We've got give the domain and the range of the relation. So I've got y equals 11 over 3 minus x, and I need to know my domain, and I need to know my range. All right, so my domain of any function for the purposes of college algebra is going to be all real numbers unless I see variables in denominators, which I do, or I see variables in radicals, which I don't. Your denominator cannot equal 0, okay? So I'm going to add x to both sides just to make it positive. So 3 cannot be x. That should make sense to you. 3 minus 3 is 0. Can't divide by 0. So you're allowed everything but 3. So on a number line, you're going to come all the way up to 3, don't touch him, and then go everything after 3. So your domain is from negative infinity to 3, don't touch, okay? And then from 3, so union 3 to positive infinity. So the soft brackets means you're going all the way up to 3 but not touching. So what's your range? Well, I'm going to assume that my range can be pretty much anything unless it looks weird. So what's the issue? The only way to make a fraction equal 0 is for its numerator to equal 0. So basically I can generate any number out there, but the one that's causing me concern is 0. I cannot make this fraction equal to 0. So I'm going to use the same little thing. My range is going to be everything but 0. I'll be able to generate everything out there. All right, so my range is going to be from negative infinity to 0, and then again from 0 to positive infinity. You'll never be able to hit 0. What does your parent function look like? It looks like that. So every y value is going to be touched except for 0. Okay? All right, piecewise define function. So my function is f of x equals, big curly bracket, 1 minus 5x, which I'm going to write as negative 5x plus 1. Okay, if x is less than or equal to 2, it's going to look like 4x if x is between 2 and 6. Okay, and it's going to look like 5x plus 4 if x is greater than or equal to 6. So I'm going to draw a little picture. I have a coordinate plane. I know that my first area of concern is 2. So here's a 2. Then I've got between 2 and 6. Okay, so I've got 3 areas. I got to the left of 2, between 2 and 6, and after 6. So I'm going to have a purple area. Okay, so if I use a number in this area, it's going to belong to the purple function. Okay, if I use a number from 2 to 6, it's going to be to that function between 2 and 6. If I use a number after 6, I'm going to use the red function. Okay, use a number after 6. Now, who owns the 2? The purple function owns the 2, so he should be purple. Who owns the 6? The red function should own the 6. Okay, so the red function owns the 6. Now all I got to do is figure out what I'm asking. So question number 1 is, what is f of 0? Okay, f of 0 is, well, where's 0? 0 is right here in purple's territory. So come up here and grab the purple function, shove in a 0. So I get negative 5 times 0 plus 1 is 1. Okay, because that would be 0 plus 1, which is 1. Okay, so the point 0, 1 is on that graph. Let's do another one. So we have, hang on, I'm filling these in as we go. All right, so the next one is going to be a 2. Who owns the 2? Purple, blue, or red? Purple owns the 2. Okay, because purple can be 2. So I'm going to grab the purple function again and shove in a 2. So negative 5 times 2 is negative 10, plus 1 is negative 9. Okay, who owns the next one? Let's see. Okay, what about f of 3? Well, where's 3? 3 is between 2 and 6, so I'm in blue territory. So grab the blue function. So negative 4 times x, so in this case, negative 4 times 3 is negative 12. Okay, so you're just finding which territory you're in. Okay, hang on, pause the world. Oh, it's positive 4. All right, so it's positive 12, sorry. I scribbled over it. All right, I panicked because it said I was wrong. All right, so f of 5 needs to be, what territory am I in? 5 is between 2 and 6, so I'm in blue territory again. So it is a positive 4 times 5, which gives me 20. Okay, so you're finding points that satisfy the pieces of the piecewise function. So now I've got f of 7, which, sorry, come back over here. Where is 7? 7 is in red territory. So I need to use the red function, which is 5x plus 4. So I have 5x plus 4, but x happens to be 7. So 35 and 4 is 39. Okay. All right, let's try one more. So I'm going to graph this thing. All right, and actually that's a good place to stop because I need to show you my screen.